So the difference between linear, so underline linear, and nonlinear, underline nonlinear, is that linear just means it's a straight line. Nonlinear means it's not a straight line. So if we want to look at all of these different charts and graphs, we want to figure out, are they linear or are they nonlinear? So the first one, Carissa's right. So we want to look at the numbers and how they're changing. So on the top, these are all going up by what?
3.
Oh, wait,
5.
No, wrong one.
Wrong one. Yeah, Desi.
Okay. On the bottom, they're all going down by what?
4.
Wow, some of you are still sleeping. Okay, are all these numbers changing at the same rate?
Yeah.
Okay, so if we were going to say this slope, we would say y over x, so that'd be negative 4/5. But the point is, they're all changing at the same rate, so this is linear. Now let's look at number 2. This x is going up by 2 each time, right? Okay. Y is going up by 2, and then it's going up by 6, and then it's going up by 10. So do you think this is linear or non-linear? Non. Wow, you're smart. I'm just going to write non for non-linear. And then 3. The top, clearly, these are all going up by 1, right? The bottom, they're going up by 2, and then 3, and then
4.
So is this linear or non-linear? Non. Good. So far, so good? All right, number 4. Same thing. The x's are going up by 3. The y's, what are they changing by?
12.
Good. Each time?
Yeah.
Yeah. So this would be linear. Number 5. The x's are going up by 2 again each time. The y's are going up by each time, right?
Yeah.
So this would be linear. Number 6. X's are going up by 1. The y's are going up by, let's see, 3, 5, uh-oh.
And 7.
So definitely
Non-liner.
non-liner. All right, now it's pretty easy to look at a graph and tell. It's easier than a chart, right? So is A right here, is this a straight line?
Yeah.
Yes, so we write linear. How about B? Yes. How about C?
No.
No. E?
No.
K?
Yes.
This one doesn't have a number. We'll call it M for Monroe. What about M?
Yes.
Who says yes? Raise your hand.
It has 2 straight lines, so.
Who says no? Raise your hand. Who says I don't know? Raise your hand. It's actually non-linear. Here's why. They're connected. They meet at 0, which means there's 2 points at 0. So that will be non-linear. If they weren't connected, you could have 2 linear lines, right? 2 linear functions. All right, what about G?
Linear.
Obviously. And H?
Non-linear.
Okay, flip it over. So we saw charts, we saw graphs, and now we need to see equations. Now equations are what we did in chapter 3. Okay? So someone raise their hand and tell me, what did an equation of a line look like? Or maybe there was an actual form. It might be on the wall still, I'm not sure. Something of a line, some sort of equation of a line. Tell me the generic equation of a line. Who knows? James knows.
Wait, no, I don't.
You sure?
Yeah.
Avi?
Y equals mx plus b.
Good. So y equals mx plus b. You can write this on the top of your paper. That was the equation of a line. Remember that y equals mx is also, right? You don't need to have the y-intercept because that means it just starts at 0. Do you remember? Good. So number 7, would you guys say that's linear or non-linear?
It's pretty linear.
Linear, right? We just said an equation of a line. What about number 8?
No.
Who says yes? Raise your hand. Who says no? Who says I don't know? This is linear, guys. We didn't really do anything different. We just has a negative slope, that's all. What about 9? It has an x squared. None, and here's why. If you ever get an exponent greater than 1, it will always be nonlinear. Okay? So any exponents greater than 1 is nonlinear. So what about 10? What is the exponent right here on this x? Do you remember back from chapter 1? When we have something on the bottom, it could, to move it to the top or bottom, remember something about what kind of exponent that would be?
It's the same as
Do you remember? Remember negative exponents?
no.
Negative, remember if we had x to the negative 1, that would be the same as 1 over x? Do you remember this? Uh-oh, this is on your final.
-1.
So this is non. All right, shh, too much chatter, guys, too much chatter.
Okay.
Shh. So right here I said anything with the exponent greater than 1, it also works for exponent less than 1. So basically anything other than 1 will be nonlinear. What about 11? Do you remember what this graph looks like?
Yeah.
What does it look like? Yes, a flat line, horizontal line going through 3. So this is a line. This is linear. What about 12? Linear, good. We just switched the order. What about 13? Not. And what about 14? Linear. Now I want to show you, I guess it's writing non, what 13 looks like really quick because this is going to come up. Well, 9, we should look at 9. 9's a parabola. Remember I talked to you about those U-shaped graphs going through 3 right here? So this 13 looks like this. It starts at 3 or it goes through 3. And it actually is a curved graph like that. Yeah, it's pretty cool, right? Okay? So clearly when you know the graph, you already know, oh, those are nonlinear, right? But if you don't know what the graph looks like, you might have to plug in some points. Or you could just look at the exponents. Any questions on that? Easy stuff, right? Okay, we're going to do some practice.